Hi, this is Sonia Doucette. In this video, I'll show you how to calculate the free energy of reaction from the enthalpy of reaction and entropy of reaction values in order to determine reaction spontaneity. The specific problem you're being asked to solve is to calculate delta G at 25 degrees Celsius for ammonium nitrate dissolution into ammonium and nitrate ions if the delta H for this reaction is 28.05 kilojoules and delta S is 108.7 joules per Kelvin. So the equation that you use to find delta G is delta G is equal to delta H minus T delta S. And there are two things to remember before you start plugging in the numbers. The first thing is that you want to convert units from either kilojoules to joules for the delta H or enthalpy value, or you want to calculate kilojoules per Kelvin from joules per Kelvin for the delta S entropy value. You can do either one of those as long as they're both in the same units of either kilojoules or joules. And the other thing that you have to remember for this type of problem is that the temperature for this equation is in kelvins. So in this case, you're given the temperature in 25 degrees Celsius, and you're going to have to convert that to kelvins before you can substitute the temperature into that equation. So let's do those conversions first. In this case, let's convert the delta S value of 108.7 joules per Kelvin to kilojoules per Kelvin. So all you have to do there is use the conversion that in 1 kilojoule you have 1,000 joules. And if you do the math there, you'll get 0.1087 kilojoules per Kelvin. The other calculation you need to do here is for temperature. So temperature in Kelvin is equal to degrees Celsius plus 273.15. So if you add 273.15 to 25 degrees Celsius, you're going to get a value of 298.15 kelvins. So now that you have your terms in consistent units, you can substitute them all into the equation to find delta G. So what you have is that delta G is equal to 28.05 kilojoules. You're given that in the problem, and you're going to subtract from that the product of the temperature, 298.15 kelvins, multiplied by 0.1087 kilojoules per Kelvin, that delta S value in kilojoules per Kelvin. And when you do the math here, what you'll find for your delta G value is that you have negative 4.359 kilojoules. So this is your answer. And then in order to determine the spontaneity of your reaction, all you have to do is look at your delta G value. And when delta G is positive, the reaction is non-spontaneous. When delta G is negative, the reaction is spontaneous. So in this case, your delta G value is in fact negative, and that means that this reaction is spontaneous.